Okay, so how would you draw a box and whisker plot on paper after you see it on your calculator? Well, you should get started by drawing a horizontal line, which is going to be scaled from the smallest to the largest data value, and it's only meant to be a guide. So our smallest data value was 10, and our largest data value was 130. So if we make a horizontal line and we label a number for every 10 data values, so 10, 20, 30, 40, etc. Okay, starting at 10 and making a notch and make the distance the same to 20 as it is to 30, etc. You're going to go all the way up to 130. And this is would be excellent to do on a piece of graph paper, making sure that the width from 10 to 20 is the same as the width from 120 to 30, etc. You're going to draw a rectangular box above the horizontal line with the sides at the first quartile Q1 and the third quartile Q3. So noting that Q1 is 29 and Q3 is 67, you draw a box approximately a little bit before the 30 to indicate the 29, and a little bit less than the 70 to represent the 67. Okay, so just try your best to make this as accurate as possible. Q1 equals 29 should be labeled below Q1, and Q3 equals 67 should be labeled below Q3. Draw a vertical line within the box to represent the position of the median. So our median was 49. Position that a little bit to the left of 50. So right in the center. Or not exactly in the center, a little bit to the right of center. Draw horizontal lines from the box to the smallest and largest data values. Those are the whiskers. So being that the smallest is the min is 12. And that's the reason why I started at 10. I didn't want to start at 12 because then it just is an odd number to begin scaling on the horizontal axis. It would make more sense to start at 10 or 5 or even 0, but you wouldn't want to start at 12. Okay, but that is the position of your whisker, of your smallest data value, so that's where your whisker should be positioned. And on the other side, your max is 130, and so you should position your largest data value at 130 and the whisker coming out from the box on the right. And that's your completed box and whisker plot. Okay, so unlike the histogram, you don't have to make the jagged line at the bottom. Again, this horizontal axis is really only for a guide. It's if you can come up with a good box and whisker plot without a horizontal axis, which is difficult, but if you come up with something that's reasonable looking, it's acceptable. Okay, let's interpret the box and whisker plot. The median represents a measure of the center, and it is denoted by the vertical line within the rectangular box. Okay, so the center of the distribution is the median. Approximately 50% of the data values are contained within the box. Okay, so from a Q1, which is 25 percentile, to Q3, the 75th percentile, we have 25 plus 25, or 50% of all the data values within the box. Within each component of the box, so the left side and the right side, separated by the median are approximately 25% of the data values. So 25% on the left side of the median and 25% on the right side of the median within the box. Approximately the lower 25%, which is this group right here, of the data values are represented by the whisker connecting the first quartile, which is Q1, to the smallest data value right here. Okay, so this is 25% of our data values. Approximately the upper 25% of the data values, this is the upper 25%, represented by the whisker connecting the third quartile to the largest data value. Okay, so this is the lower 25%, this is the upper 25%. Okay, we say lower because these are the lower values, and upper because these are the higher values. The length of the box is a measure of the variability of the data set. Okay, so we looked at measures of variability using numerical techniques in the last couple lectures. So a measure of variability could be the standard deviation or the variance. Those two give us numerical measures for variability in data sets. But if we look at two box and whisker plots, the length of the box is a measure of variability. So if we have a shorter box, it indicates less variability. A longer box would indicate more variability. So if you had to compare two box and whisker plots and decide which distribution had the greater variability, it would be the distribution with the longer box. The length of the whiskers provide an idea about the shape of the data set. If one whisker is noticeably longer, then the shape of the data set is probably skewed in the direction of the longer whisker. Okay, so the longer whisker on the right-hand side is there because the largest data value, if we think about our last example, that's a good one to look at. Okay. Okay, we have a really long tail, or rather a long whisker on the right-hand side. This means that this box and whisker plot is skewed right. Okay, why is it being pulled out to the right? Because it has a maximum of 130, where most of the data values in the distribution were not near 130. A lot of them were a lot lower than 130. In fact, 75% of them were at or below 67. Okay, so 75% of the data values have values at or below 67. So that 130 and a couple of the other large data values have the effect of pulling this whisker out to the right in a greater way than the min of 12. Okay, the min of 12 is not too far away from the 29, but the max of 130 is much further away from the 67. So this is a skewed right distribution. If the same kind of length whisker appeared on the left-hand side while the right-hand side were short, it would mean that the distribution was skewed left. If they're both the same size, it would represent a symmetrical distribution. Okay, so if one whisker is noticeably longer, the shape of the data set is probably skewed in the direction of the longer whisker. So skewed right or skewed left, depending on whether or not the whisker is longer on the right or the left. Okay, if we look at three images starting in the center at a symmetric distribution, we looked at symmetrical bell-shaped distributions, and the bell is perfectly symmetrical on the left and the right. It would produce a box and whisker plot where the box has a median that seems to go right down the center of the box, and the whisker on the right is the same length as the whisker on the left. If you look at a skewed left distribution, so the bell-shaped curve looks like this, where the tail on the left is being pulled out because of there's extreme low data values in the distribution. When a box and whisker plot is produced off of a skewed left distribution, you're going to have a left whisker that's longer than the right whisker, and the box in the center is going to show that the median is positioned a little bit to the right of center. A skewed right distribution, here's the image of a skewed right distribution where the tail on the right is being pulled out because of extreme large data values in the distribution. You're going to have, when the box and whisker plot is produced, you'll have a longer whisker on the right than on the left, and your median will be positioned a little bit to the left of center in the box.